Okay, this is our next question. Please read this question, all of you. A sinusoidal source of voltage, that means what? We have a sinusoidal voltage source which has a phasor voltage of capital V and frequency F is connected to a series circuit of variable resistance R and a fixed positive reactance X. That means what? We have a resistor and some impedance in series. We have some resistance and an impedance both connected in series across what? This sinusoidal voltage source. What is the locus of the tip of the current phasor I, as the value of the resistance is what? Varied from 0 to infinity. So if you draw the circuit, it will become more obvious. Okay. So what do we have here? We have a sinusoidal voltage source. Let it be capital V. And across this, two elements are connected. One is what? The resistance R. Another is some impedance whose reactance is what? X. Whose reactance is what? X. It is also given that the reactance is what? Positive. So if any element has got only reactance, then the impedance would it not be J times the reactance, because in general the impedance would be what? R plus Jx. But if it's a reactive element, then R is going to be 0. Then the impedance is simply going to be what? J times the reactance. Okay. So let me write the impedance of this element as what? Jx. Okay. And the loop current, let it be capital I. So here V is what? Fixed. So V is what? Fixed. Omega, that is the frequency of the source, is also fixed. The reactance value, that is what? The value of X is also fixed. What is being varied? The value of the resistance is varied from 0 to infinity. So when the value of R is being varied from 0 to infinity, what is the locus of the tip of the current phasor I? You see, when R is what? Varied from 0 to infinity, even the phasor I will keep moving on the complex plane. Yes, so for different values of R, you will get different phasors. Okay, so you draw all the phasors for different values of R. Once you draw all the phasors for different values of R, then you join the tips of all the phasors. You join the tips of all the phasors, then you will get the locus of the tip of the current phasor I. Locus means what? Path traced by the tips of the current phasor I, as R is varied from 0 to infinity. Okay. Please try it. I mean, it's very simple. See, first of all, what is I? I is what? The loop voltage, that is what? Capital V divided by the net impedance in the loop, which is R plus Jx. V upon R plus Jx. Okay. Now you see, nothing is given about V. So what we can do is, let's assume V is what? Some Vm angle 0 degrees. Let's assume V is what? Some Vm angle 0 degrees. Now in place of V, I can write Vm angle 0 degrees divided by, let me write R plus Jx. Now what is this R plus Jx in polar form? R plus Jx in polar form, first let me write Vm angle 0 degrees divided by R plus Jx in polar form would be square root of R square plus X square, and then angle tan inverse X by R. So what is the final expression for the phasor current I? Look at the expression for capital I. The magnitude, would it not be Vm divided by square root of R square plus X square? Vm divided by square root of R square plus X square, and then you should subtract the denominator angle from the numerator angle. Numerator angle is what? 0 degrees. So what is the overall angle? 0 degrees minus tan inverse X by R. So the overall angle is what? Minus tan inverse x by r. Now here in this expression for the phasor current capital I, everything is fixed except the value of r. R will be varied from 0 to infinity. Yes, for any phasor there will be two things. One is what? The length of the phasor, which is same as what? The magnitude of the phasor. The other thing is what? The angle of the phasor with respect to the positive real axis. Yes, magnitude, which is same as what? Length. And the angle of the phasor, which is same as what? Angle of the phasor with respect to the positive real axis. Okay. So here, so what is I? Vm divided by square root of r square plus x square at an angle minus tan inverse x by r. Now the point is what? The value of r is varied from 0 to infinity. Value of r is varied from 0 to infinity. How will the mod I vary? When r is 0, 0 square plus x square, square root is what? X. So will it not be Vm by x? And then as r tends to what? Infinity, denominator infinity, this magnitude, would it not become 0? So look at the mod I value. When r goes from 0 to infinity, mod I, is it not decreasing from a maximum value of what? Vm by x to 0. So as the value of r is varied from 0 to infinity, the phasor becomes shorter and shorter. For r equal to 0, the phasor is what? The longest. And for r tending to infinity, the phasor becomes what? 0. That means the length of the phasor is what? 0. Phasor length 0, that means what? It's like a dot. It's like a point where at the origin, because every phasor, the starting point is what? The origin. It starts from origin, but the length is what? 0. It is just a point at the origin. Okay. The other thing for any phasor is what? The angle. Angle means what? Minus tan inverse x by r. Again, the initial value of r is what? 0. If r is 0, tan inverse x by 0. Remember, it is given that x is what? Positive. Tan inverse any positive value by 0 is what? Tan inverse infinity. Tan inverse infinity is what? 90 degrees, but you also have this minus sign. So what is the angle of the phasor current I? Initially, it is what? Minus 90 degrees. Angle minus 90 degrees, that means what? The phasor, will it not be along the negative imaginary axis? Angle minus 90 degrees, it means what? The phasor would be along the negative imaginary axis. And then r will eventually become what? Infinity. When r becomes infinity, tan inverse x by infinity. Anything by infinity is what? 0. Tan inverse 0 is also what? 0. Plus 0 or minus 0, it is what? 0. That's all. This is how the angle of the phasor current I varies when r is varied from 0 to infinity. Look at the angle. Is it not going from minus 90 degrees to 0 degrees? So is it not rotating in which quadrant? Please comment in the chart box. The phasor I will rotate in which quadrant? Minus 90 degrees to 0 degrees. Phasor rotates in which quadrant? Minus 90 degrees is what? Negative imaginary axis. 0 degrees is what? Positive real axis. So from negative imaginary axis, it gets aligned with positive real axis. It will rotate in the clockwise or anti-clockwise direction. Anti-clockwise direction in the fourth quadrant. Okay, everybody says fourth. Very good. Look at this. So once again, this is what? The positive imaginary axis. This one is what? The positive real axis. Initially when r is what? 0, the phasor will have maximum length. And what is that maximum length? Vm by x. And what is the angle? Initially minus 90 degrees. So will it not be something like this? Yes. You can say it has a length of Vm by x. The length is what? Vm by x. And it is aligned with the negative imaginary axis. Then as the value of r goes from 0 to infinity, the phasor will rotate towards what? The positive real axis. But as it rotates, the length of the phasor, it keeps decreasing. Okay. So it will do this, it will do this, it will do this, 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 and finally like this. That's all. this is how the phasors are going to be. Okay. Now the question is what is the locus of the tip of the phasor current I? That means what? You just have to join. So here I have drawn a few phasors that will indicate how the magnitude and the angle are going to change when R is varied from 0 to infinity. So once you draw a set of phasors, you just join the tips. You just join all the tips. When you join all the tips, you want to get something like this. Let me just rewrite. You will get something like this. I hope you can see this. So what is the shape of the locus? When I joined all the tips, did I not get this yellow color curve? Please tell me what is the shape of the yellow color curve, which is the locus. Is it not a semicircle? Do you all agree with that? The locus is what? A semicircle. Yes or no? Look at what I obtained. When I joined all the tips of the phasors, I get this yellow color curve, which clearly looks like what? A semicircle. Okay. So the locus is what? A semicircle. I hope it is clear. Okay. So any locus problem, first you write down that phasor current or phasor voltage for whatever quantity you are trying to find the locus. Obtain the polar form representation of that phasor current or voltage. Now from the polar form you will get both magnitude as well as amplitude. So when any parameter, in this case the resistance value is what? Varied from one value to another value. Both the magnitude and the angle will vary. Just write down how the magnitude is going to vary. Also write down how the angle is going to vary. Once you know how the magnitude and the angle are going to vary, you draw a few phasors, you just join all the tips, you will get the locus. This is how we go about problems related to locus. Okay. I think we have one more question related to locus. Read the question. A series RC circuit. Series RC, it only means what? R and C are connected in series across some source. Okay. A series RC circuit is excited by a 1 at an angle 0 degrees sinusoidal AC voltage source. That means what? We have a resistor in series with a capacitor across a sinusoidal voltage source whose phasor voltage is given as what? 1 at an angle 0 degrees volts. What is the locus of the tip of the phasor current I? Once again, single loop circuit. Let the loop current be some capital I when C is varied while keeping R fixed. So now also it is understood that C is what? Being varied from 0 to infinity. The value of R is what? Fixed. Okay. Again, you should do the analysis in the phasor domain. In the phasor domain, the capacitor, it becomes what? An impedance of value 1 by j omega C. And by the way, the frequency of the source is also what? Fixed. Okay. So what is being varied? It is only the capacitance value that is varied from 0 to infinity. Everything else will remain constant. And that includes what? The frequency of the source. So omega is also what? Fixed. Okay. Anyway, what is the expression for the loop current? Look at this. I, will it not be the applied voltage or the applied phasor voltage, which is 1 at an angle 0 degrees, divided by the net impedance in the loop, which is R plus 1 by j omega C. Again, this is same as what? 1 at an angle 0 degrees divided by R minus j by omega C. R minus j by omega C. Now let us express this current in proper polar form. Okay. Look at this. 1 at an angle 0 degrees. What is the magnitude of the denominator complex number? Square root of R square plus 1 by omega square C square. And then angle. Angle is what? Tan inverse imaginary part divided by the real part. If you look at the denominator complex number, the real part is what? R is always going to be positive. Value of resistance is always positive, okay? And the imaginary part is what? Minus 1 by omega c. Imaginary part negative, real part positive. Clearly this complex number in the denominator would lie in fourth quadrant. Any complex number that lies in fourth quadrant will have an angle which is negative and which is between 0 and minus 90 degrees, okay? So what is the angle of this? Directly I will write it as minus tan inverse imaginary by real 1 by omega c divided by r, which is minus tan inverse 1 by omega cr. I hope it is clear up to this point. So what is the overall magnitude? 1 divided by square root of r square plus 1 by omega square c square. What is the overall angle? Angle of numerator minus the angle of denominator. When you subtract this angle from 0 degrees, 0 minus of minus, would it not become positive? Yes. So on the next slide, I will write the expression for the current. So I is what? 1 divided by square root of r square plus 1 by omega square c square at an angle 0 minus of minus, it becomes what? Plus tan inverse 1 by omega cr, okay? That's all. So this thing is what? Mod I. This is what? Angle I. Now which parameter is varied from 0 to infinity? The value of the capacitance, it goes from 0 to infinity. When the value of C goes from 0 to infinity, what about the mod I? That is the magnitude of the phasor current I. When C is 0, 1 by 0 is what? Infinity. Infinity plus anything is what? Infinity. 1 by infinity again is what? 0. So the mod I value is also going to be 0. Now when C tends to what? Infinity, 1 by infinity is what? 0. R square plus 0 is what? R square. Square root of R square is what? R. So it is going to be 1 by R. So what is happening to the magnitude of the phasor current I? Is it not increasing from 0 to 1 by R? That means as the value of C goes from 0 to infinity, the phasor becomes longer and longer. Yes. And what is the longest value of the length of the, or what is the highest value of the length of the phasor? It is 1 by R, and that is when C tends to what? Infinity. What about the angle of the phasor? Angle of the phasor. Angle of the phasor is what? Tan inverse 1 by omega cr. Again, initially C is what? 0. C0, 1 by omega cr will be what? Infinity. Tan inverse plus infinity is what? 90 degrees. And then as C tends to infinity, 1 by infinity is what? 0. Tan inverse 0 is also what? 0 degrees. So look at the variation of the angle of the phasor current I. It varies from 90 degrees to 0 degrees. 90 degrees or plus 90 degrees, that means what? The phasor would lie along the positive imaginary axis. 0 degrees again is what? Positive real axis. So is it not going to rotate in the first quadrant? Yes, semicircle in the first quadrant. Very good. Anyway, I'll just draw a few phasors and then join all the tips to get the locus, okay? So this again is what? The positive imaginary. This is what? The positive real. So initially what is the length of the phasor? Initially the phasor has a length of what? 0. Length 0, that means what? It's like a point at the origin. Yes. And then the length keeps on increasing and the phasor will rotate from positive imaginary axis towards the positive real axis. Positive imaginary towards positive real. That means what? It will rotate in the first quadrant in the clockwise direction, okay? So would it not do something like this? So initially it is what? A point. Initially it is what? A point. Then so these are the various phasors. So you can see it rotates towards what? Positive real axis. At the same time the phasor becomes longer and longer. So once I draw these phasors, I'll just join the tips. When I join the tips, I sort of get a semicircle. Okay, so what is the shape of the locus? It is a semicircle, which you can see it lies in first quadrant. Okay, semicircle lying in first quadrant. So if I ask you what is the diameter of the semicircle, what is the diameter of the semicircle? Is it not 1 by r? Because what is the length of the phasor as c tends to infinity? It is 1 by r. Yes. So here the diameter of the semicircle is what? 1 by r. Okay. Anyway, are you able to read the equation? So I'll just read it. For the circuit shown in figure, in fact, what circuit is this? Is it not a simple RC circuit? It is what? A simple RC circuit. Any RC circuit will have a time constant, which is what? R into C, and the time constant is what? 1 millisecond. So here the value of tau is given. So tau, which is RC, is what? 1 millisecond, which is 10 power minus 3. Okay. The input voltage, this is what? The input voltage, and the output voltage is what? Across the capacitor. Okay. So for this RC circuit, the input voltage is what? √2 sine 10 power 3 t. So Vi of t, that is what? Voltage applied across the RC circuit. As a function of time, it is what? √2 sine 10 power 3 t units volts, and the initial voltage across the cap is given V0 of 0. V0 of 0 is what? The initial voltage across the cap. It is given as 1 volt. You should find the output voltage, that is what? Voltage across the cap, as a function of time for t greater than 0. Yes, you should find what? V0 of t for t greater than 0. If you are finding V0 at steady state, if you are finding V0 at steady state, then you can just do the analysis in phasor domain. You will get the phasor voltage at steady state, and then convert that phasor into its time domain representation. You will get V0 of t at steady state. But here we are asked to find V0 of t for t greater than 0. That means even before reaching steady state, how will the output voltage vary with time? This is the actual question. So doing the phasor analysis and just leaving it there will be an incomplete solution. You should also find which response? You should find steady state response or complete response. Please type in the chat box. You need to find the steady state response only or the complete response. Complete, right? You should find the complete response. So if you recall, the complete response of any circuit will consist of how many parts? Complete response of any circuit will consist of 2 parts. What are the 2 parts? The natural or the transient response, and of course the steady state or the forced response. Okay. So here V0 of t will have 2 parts. NR is what? Natural response, and then the forced response or the steady state response. What is the order of this circuit? What's the order of the circuit? Is it not a first order circuit? Any first order circuit, the natural response will be of the form A into e power minus t by tau. Yes or no? Any first order circuit, the natural response is going to be of the form A times e power minus t by tau. This is the form of the natural response of any first order circuit, whatever be the source driving the circuit, whether it is DC source or sinusoidal source. The natural response of a first order circuit is always going to be something like A times e power minus t by tau. Now to this you should add the forced response, which is also called the steady state response. Now to find the steady state response, yes, you should do the analysis in phasor domain. Okay. Anyway, see. Now in the phasor domain, R will remain as what? R, whereas the capacitance will become an impedance of value 1 by j omega c. So can't we use voltage division? So V0, phasor voltage V0. Right now we are doing analysis in the phasor domain to find the second component of the response, that is what? The forced or the steady state response. Okay. So what is V0? Capital V0 going to be? Will it not be capital Vi times the impedance of the capacitor, which is 1 by j omega c, upon Z1 plus Z2, which is like R plus 1 by j omega c. Okay. So this can be written as what? Vi upon 1 plus j omega rc. What is the frequency of operation? By the way, this 10 power 3, is it not omega? Yes. So what is omega? It is 10 power 3. What is RC? It is 10 power minus 3. So what is omega RC? Look at this. Omega is what? 10 power 3. RC is what? Time constant, which is 1 millisecond. That is what? 10 power minus 3. So what is omega RC? 10 power 3 into 10 power minus 3. Is it not 1? So here, omega RC is what? 1. If omega RC is what? 1, our phasor output voltage V0 at steady state, would it not be Vi upon 1 plus j? Because omega RC is what? 1. It simply becomes what? Vi upon 1 plus j. Again, this 1 plus j is what? In rectangular form. What is 1 plus j in polar form? Root 2 at an angle 45 degrees. So Vi divided by root 2 at an angle 45 degrees. This is what? The phasor voltage or the phasor output voltage V0. So V0 is what? Vi divided by root 2 at an angle 45 degrees. What is the applied input voltage? Root 2 sine 10 power 3t. So this divided by this root 2 and this root 2 will get cancelled, and then there will be a phase shift of minus 45 degrees. Yes or no? So directly I'll write the steady state or the forced response as what? Root 2 and root 2 get cancelled out. We are simply going to have sine of 10 power 3t minus 45 degrees. That's all. This is the complete expression for V0 of t. Natural response, because it's a first order circuit, will be the form A into e power minus t by tau, and then the steady state response, which is always going to be sinusoidal at the same frequency, but with some different amplitude and also a different phase angle. Okay. Now the only thing that is unknown in this expression is what? The capital A, value of capital A. How do you find the value of capital A? By using the initial condition. Already it is given that the initial voltage across the cap is what? 1. So here you substitute t equal to what? 0. So V0 of 0. If you put t equal to 0, e power 0 is what? 1. So is it not just A? A plus, again if you put t equal to 0, sine of 0 minus 45 degrees. What is sine minus 45 degrees? Is it not minus 1 by root 2? So A minus 1 by root 2. Now the given initial condition or the initial voltage across the cap is what? 1. So from here, what is the value of A? Is it not A plus, 1 plus 1 by root 2? 1 plus 1 by root 2. What is 1 by root 2? What is 1 by root 2? 0.707, is that correct? 1 by root 2, I believe it is 0.707. So 1 plus 0.707 must be 1.707. That's all. Now we can write the complete expression for V0 of t. So in place of A, you write 1.707 e power minus t by tau. Remember, tau is what? 10 power minus 3. 1 by 10 power minus 3 is what? 10 power plus 3. So is it not going to be e power minus 1000 t? 1.707 times e power minus 1000 t plus the steady state response, which is sine of 10 power 3t minus 45 degrees. Units are volts. That's all. So the first term is what? The transient response. If you look at the transient response, it contains what? A decaying exponential. So after a long time, the entire first term will decay to what? 0. So what will remain in the long term is only the steady state part of the response. You understood? So always we assume transient has become what? 0. Then the only thing that will be left is what? The steady state part of the response. Okay? Is it clear? Yes?